In this section of the course, we're going to cover DevOps and cloud security. As we go through the section, we'll be focused inside of Domain 3, Management and Technology, with Objective 3.2, as well as Domain 4, which is Governance, Risk, Compliance, and Security for the cloud, with Objective 4.4 being our focus in that one. Objective 3.2 states that you must be able to explain DevOps in cloud environments, and we will specifically be focusing on continuous integration and continuous delivery, also known as CI/CD, provisioning, configuration management, API integration, and quality assurance testing. We will also be covering Objective 4.4, which states that you must be able to explain security concerns, measures, or concepts of cloud operations. And we'll be focused on the shared security model used in cloud computing, security assessments, data security, applications and infrastructure security, and also network connection security. Now, as we begin the section, we will discuss DevOps. DevOps is a software development methodology that emphasizes collaboration and communication between development and operations teams. The goal of DevOps is to automate the entire software delivery process from code development and testing to deployment and infrastructure management. By integrating development and operations teams and automating the software delivery process, organizations can improve the speed, quality, and reliability of the software. Next, we'll discuss continuous integration and continuous delivery. Continuous integration, or CI, is a software development practice where developers integrate their code changes into a shared repository very frequently. This practice allows developers to detect errors and conflicts in code changes early in the development process. Continuous delivery is a software development practice where code changes are automatically built, tested, and deployed in production systems. The goal of continuous integration and continuous delivery is to make software delivery fast, reliable, and automated. Then we will discuss provisioning, including infrastructure as code and the use of templates. Provisioning is the process of setting up and configuring resources for an application or a service. These resources can be provisioned automatically in the cloud by using infrastructure as code tools, which allow administrators to define infrastructure and configuration as lines of code. This infrastructure as code can be also combined with the use of templates to easily provision resources, which in turn reduces the time and effort required for manual configuration. By utilizing templates, you can automate the provisioning of resources such as virtual machines, storage, and network components. After that, we will cover configuration management, including the use of orchestration, automation, upgrades, and patching. Configuration management is the process of managing and automating changes to a system's configuration. Configuration management tools enable administrators to automate the provisioning and management of infrastructure and applications, including upgrades and patching. Orchestration and automation can be used to provide a framework for managing and automating complex, multi-tiered applications. These configuration management tools also enable administrators to manage and enforce compliance policies across their environment, ensuring consistency and security. Next, we'll discuss the concepts surrounding API integration. API integration is the process of integrating different software systems using APIs, or application programming interfaces. APIs enable different software systems to communicate and exchange data with each other. API integration is an important aspect of DevOps and cloud operations, as it enables the integration and coordination of various services and applications, enabling organizations to build more scalable and flexible systems. Then, we will discuss quality assurance testing, including the use of sandboxing, load testing, and regression testing. Quality assurance testing is a process of ensuring that software meets the desired quality standards. This quality assurance testing can be automated using various testing frameworks and tools. Sandbox environments are isolated testing environments used to safely test and develop new features or applications. Load testing is used to measure the performance of a system under normal and peak loads. Regression testing, on the other hand, is used to verify that changes or updates to a system do not break existing functionality. By using these different testing methodologies, organizations can ensure that their applications and services are reliable, scalable, and secure. After that, we will discuss shared security model using cloud computing environments. In the shared security model, cloud provider is responsible for the security of the infrastructure, while the customer is responsible for the security of their applications and data. This means that while the cloud provider is responsible for securing the physical infrastructure, network, and hypervisor, the customer is responsible for securing their applications, data, and user access. By understanding and implementing the shared security model, organizations can ensure that their cloud environments are secure and compliant. Next, we'll discuss different types of security assessments used in cloud, including penetration testing, vulnerability scanning, and application scanning. A security assessment is a process of evaluating the security of a system or environment, such as a cloud environment, to identify potential security risks or vulnerabilities, evaluate the effectiveness of existing security controls, and recommend improvements or additional security measures to mitigate identified risks. Penetration testing is a process of attempting to exploit system vulnerabilities to determine whether unauthorized access or other malicious activities is possible. Vulnerability scanning involves the use of automated tools to scan for and identify vulnerabilities in a system or application. Application scanning is a process that examines the source code of an application to identify potential security vulnerabilities or flaws. By performing these security assessments in the cloud environment, organizations can identify and mitigate potential security risks, ensuring that their applications and data are secure. Then we'll discuss data security in the cloud, which includes the CIA triad. The CIA triad is a widely accepted security model that defines three key security concepts: confidentiality, integrity, and availability. Confidentiality refers to the protection of sensitive information from unauthorized access or disclosure. Confidentiality measures are used to ensure that data can only be accessed by authorized users or systems. Integrity refers to the protection of the accuracy and consistency of data. Integrity measures are used to ensure that data is not corrupted, modified, or deleted without proper authorization. Availability refers to the ability of users to access and use data or systems when needed. Availability measures are used to ensure that systems and data are available to authorized users when they need them and are not disrupted by any failures or attacks. After that, we will cover the concepts surrounding application and infrastructure security, including auditing, access, authorization, and hardening. Application security is a process of protecting applications from unauthorized access, use, modification, or destruction. Application security involves the use of security controls such as encryption, access control, and input validation to ensure that applications are protected from potential security threats, such as SQL injections or cross-site scripting attacks. Infrastructure security, on the other hand, refers to the protection of the underlying system, networks, and resources that support the applications. Infrastructure security involves the use of security controls such as firewalls, intrusion detection and prevention systems, and also security information and event management systems. Now, these help to protect infrastructure from being potential security threats such as malware or denial of service attacks. Both application and infrastructure security are important components of a comprehensive security strategy, and organizations should ensure that they have appropriate security measures in place to protect both their applications and their underlying infrastructure from potential security threats. To achieve a higher level of application or infrastructure security, it is important to use auditing, access, authorization, and hardening as part of your assessment. Auditing involves the review and analysis of system logs and events to detect and respond to potential security threats. Access control is a process of managing and restricting user access to applications and data, ensuring that only authorized users can access sensitive information. Authorization involves defining and enforcing policies that specify what actions users can perform and what resources they can access. Hardening is a process of configuring and securing a system or application to reduce its attack surface and protect it against potential security threats. Next, we'll discuss the security of your network connections in the cloud, including VPNs, direct connections, networking services, DNS, and firewalls. Using VPNs or virtual private networks or direct connections are two common methods of securely connecting to cloud resources from external networks. Network services such as DNS, domain name systems, and load balancers can also be used to provide secure and reliable access to cloud resources. Firewalls are used to control network traffic and prevent unauthorized access to cloud resources. Finally, we'll perform a quick demonstration so you can see how these cloud principles are applied in the real world, and then we will take a short quiz to see what you've learned during this section of the course. Then we'll review each of those quiz questions to fully ensure that you can explain why the right answers were right and why the wrong answers were wrong. So let's get ready to dive in DevOps and cloud security in this section of the course.